welcome. In this lecture, we are going to talk about hardware case study and transient performance in digital voltage mode control buck converter. So, we are first going to consider design case study of the digital voltage mode control, experimental load transient performance with case studies and experimental reference transient performance. So, in digital voltage mode control buck converter, we have discussed in detail. These are the power stage details that we have discussed multiple times, and initially we are considering the 3.3 volt input, and this is the design parameter for 3.3 volt input, which we have discussed in the previous lecture, which were considered the simulation case study derivative gain. Only we have reduced the integral gain because otherwise in hardware there are some other unmodeled dynamics and delay. So, we have reduced the integral gain to avoid under like a otherwise it will lead to lot of damping issue, it will become more under damped. So, we have reduced the integral gain. We have kept the same proportional derivative gain. ADC resolution effectively we have taken 9 bit, though it is an 8 bit 10 bit ADC, and then controller frequency 100 megahertz that we have discussed, RAM 2 volt, voltage feedback gain 0.27. We have discussed multiple times of the digital voltage mode control, this architecture which will be inside an FPGA. Now, we are first considering our first case study of load step transient, where 3.3 volt input and 1 volt output, and the load resistance is changing from 13.5 to 0.322 ohm and back, because there is step up and step down, and we are designing using alternative approach. Kp and Kd are coming from the design which we made in the previous lecture, only we have reduced Ki and limited to 0.2. And this is the load transient performance, and you can see that it is a nicely damped system for load which was like it is changing from roughly 17 milliampere to 3.07 ampere, and where the load step size is roughly around 3 ampere. So, the undershoot and overshoots are much within limit, and it is more or less a well damped response. This is a zoom version of this, and you can see that undershoot is, if we consider this average, it is roughly 100 millivolt, and the settling time is coming to be around 25 microsecond, which is reasonably fast, like a 5 cycle or so. Okay. And if we take the step down, the overshoot is also going around, I think if you take the average value, because the measure point, if we measure right across the capacitor, then you will see this spike will get reduced and you will get more or less the average value. So, this average value, if you see this overshoot will be around 130 millivolt or so, and it is the response time is coming within like half of this. So, it is like 30 microsecond, which is 6 cycle. Now, we are talking about reference step up transient. The reference step up transient, if we take the zoom version of this, so this is the reference step up transient in the average sense. So, there is an additional overshoot of around 50 millivolt, and it is changing from 1 volt to 1.1 volt, and this is happening like around 30 microsecond. And the step down, it is like coming in within this time period. So, which is like around 30 microsecond with an additional undershoot of roughly around 100 millivolt. Okay. So, that means we have designed this both step up and step down, we have designed the voltage mode controller using our alternative approach. Now, here we are considering 5 volt and 1.8 volt, where the load step, again load resistance remains same, but now there is a step up transient from 70 milliampere to, because it is a 5 ampere scale and it is going to around 5. So, that means it is changing from 70 milliamp to roughly 5 ampere. But you see the undershoot, this is if you consider 5 volt. So, this voltage is 1.8 volt, and each division, if it is 100 millivolt, so it is going around 20 millivolt, that means additional, like it is coming up to here it is 5. So, 1 2 3 around 200 millivolt drop, and it is reaching within 1 2 3 4 cycle. That means roughly around settling time is around 30 microseconds, so 6 cycles. So, it is a well damped response even for a large load step transient. So, we can achieve very nice transient performance by this alternative approach. So, in summary, we have discussed design case study of digital voltage mode control. We have shown experimental load transient performance as well as experimental reference transient performance with case studies. That is it for today. Thank you very much.